Sunday today, and I finished cleaning up the last of the valve parts. I cleaned up the valve gear and the tappets and things. I am going to need new valve guides, possibly new valves, depends where the wear is, but the valves were a bit sloppy in the guides, so I'll need to fix all of that. Mainly I've been working on the body for the Brooklands, the rear half of the body. That's more or less all the welds ground down, filed down now, and I've started going through and hammering it smooth. I had it fairly smooth, and then I put it back on the frame and realized it needed a bit of adjusting with a big hammer. So I did that, which means I now have to re-smooth some of this off. The welds are much better. I haven't had any welds crack, which is great. There are a few small sort of pinholes and defects I'm going to go through and touch up, probably tomorrow. You can see I've marked those. It's all been filed. It sticks out a little bit here, which is a bit annoying. I just need to change the shape there a little bit. With a clamp there, it does pull it into the right place. And I've also gone around and marked all the way around the outside, so I can actually trim it neatly next time I take it off this frame. So it's getting there. I'm never going to get it perfectly smooth. It's always going to be a bit ripply, but looking at the real race cars at Southwards Museum, they're all ripply, so I think it'll be fine. Kind of skimmer to fill in some of the little sunken bits. I have been trying to hammer and weld those out, but I just get worried that, or hammer and file those out, but I worry if I do that too much I'll make it too thin. So I'd rather leave the surface, have these little depressions, and they can be filled. So that's what I've been doing all day. It actually started off a nice sunny day, and I was able to cut the grass, and I actually had to go in and put on some sunblock. I may have got a little bit of sun today, and then it started raining again, so it's a bit soggy now. All the tools I've been using, so it's looking pretty good, I think. I'm in my little lab, and I've been reading the book that I got from the swap meet a few weekends ago now. I think it was $5, this book. It's a book from, I think it was 1930. The date on it is 1930. So it's the exact right era for the cars I'm into. It's got an inscription there, 1930. And it's a really neat little book. I took it with me on the train going to work the other day and started reading it, and basically I didn't get very far, and I hit a section where they're talking about engine balancing, and it goes through the different sort of layouts of engines, and it gets to the four-cylinder engine, and it mentions that in a four-cylinder engine where you've got basically four pistons going up and down, usually they're arranged so the two outer ones and the two inner ones are on the same kind of throw on the crankshaft. So if you look at an engine, you'll see the middle two pistons move together and the outer two pistons move together. And this book talks about the balancing of the pistons, and what it mentions is you can't actually balance a four-cylinder engine like that because the forces aren't equal. And it turns out that the velocity of the pistons on the downward stroke at any given point aren't the same as the velocity on the pistons on the upward strokes. It's very counterintuitive. You would think that they're the same, and you'd also probably think that the maximum velocity is when the crank is at 90 degrees. It turns out that's not true. And this book kind of mentions that you know, you can work it out yourself with a picture of an engine and a pair of compasses. We've got better these days. We've got spreadsheets, and I think I've mentioned a few times I really like spreadsheets. So I looked into this, and yeah, it turns out it's true. There's a Wikipedia page that actually gives you the formulas. This one to calculate all of this. It uses some differentiation basically to work out the velocity and the speed of the pistons going up and down in the bores, given the crank throw and the length of the rod. So I took those formulas and put them into a spreadsheet. So I've got the crank angle. I've got two pistons here, and I've got a crank angle where they're 180 degrees apart, and I just used a crank throw of 50. The units don't really matter, and a rod length of 100. That seems about right. That would be like a 2-inch throw and a 4-inch long rod. So I might actually try this with numbers from the Riley 9 engine. I can't remember the sizes off the top of my head. Like I say, it doesn't matter, and I can change the numbers here. So I basically created the little formulas, which are horrendous. I had to get all the bracketing right. This is for the velocity. The acceleration gets... Don't want to screw up my formulas. The acceleration gets even worse. I think it's the first time I've ever done a spreadsheet where I needed 2 lines to show the formula. But if you plot these out, so I just have every 5 degrees for a 360 degree rotation, and I plotted out the chart of what you get, and it's pretty much what it shows in the Wikipedia article. This red line is the velocity of the first piston, and this blue line is the velocity of the piston that's 180 degrees out. And you can see the velocities, the maximum velocity doesn't happen at 90 degrees. So you can see on this one, it happens before 90. And on the other one, it happens after 90. And this is because one is going up and one is going down. 180 degrees, of course, the velocity on both of them is 0. They cross over, and then you get the opposite. And if you look at the acceleration, you get this weird little bobble, I guess. It's really interesting how that works, and it's all just to do with the trigonometry of the crank throw and the fact that the crank is kind of off center and moving around in an angle. Yeah, it was just interesting, and I had to sort of plot this out for myself to see how it worked. Yeah, really quite interesting that how that works. Today is Monday, public holiday here, and been working on the Riley, of course. The first thing I did this morning was came out and played a bit more with my TIG welding. I actually wanted to try going back to the original aluminium TIG rod that I got, which is this stuff. It's 1.6 mil 5356. This would have been from Bock. Yeah. Because I figure thinner filler rod is going to mean less material to have to grind and file off. So I did a test on a piece of aluminium, and I welded it with that filler rod, and I didn't actually end up grinding the weld. I ended up hammering it flat because I wanted to see if it would crack. You can see where I've been hammering it, and I was actually able to planish it pretty smooth. What I ended up doing was running a bead on the front. You can see I started off a little wonky, but it got better. And then I just went on the back and just did like a fusion weld to bring the back edges together, and hammered it smooth. It cracked on the edge here, but that's quite normal. But it didn't crack in the middle. And then I basically took it to the sandbag and used my big mallet, this one here, and beat the crap out of it until it broke. and it didn't actually break. You can sort of see a line there, which I think is where the two edges of the metal are joined, but it hasn't actually cracked all the way through. So I think that rod will work pretty well. So I use that to patch up the little holes. I've still got one more pinhole up on the top here somewhere there, which I need to fix. And then I ran out of welding gas, so I need to go get more gas this week. And again, trying to just hammer it and file it to get it smooth. I have trimmed it. So the way I do that is I put an inch wide strip of tape all the way around, and I use that to mark where to cut. Something went wrong at the bottom, because when I marked it, I thought I had too little material. I think it was when I traced the line, I didn't have the corner of the Sharpie up against the timber, so I do actually have enough there to wrap that around. So it's going to need a final trim. I haven't done the final trim on this yet. I've left this slightly oversized. You can see there's two strips of tape, so that needs trimming. I'm a little bit worried about the shape just in here. You can see there's a gap, and I think that's because I found I needed to bring the body in there a little bit to clear the suspension, I think. I do remember I ended up grinding a bit more off the timber here, and that's why it's not fitting, because it's not a fair curve anymore. So I'm hoping by the time I cut this out, I'll be able to hammer this round so that it takes up that gap. I should be able to. There's a bit of spring in this. It's quite hard to clamp it fully down because you can't clamp it in the middle. But I'm pretty sure that will be able to be clamped and then hammered round, especially once I cut that opening out. I haven't done that yet. I'll do that when I do the final trimming. And I also trimmed the tail, which meant removing more off the rear corner there. I had that corner far too sharp, so a lot of sanding there. This is now a really good fit, especially when it comes time to weld it. I can hammer these edges to get them to fit perfectly, but that fits really well. And I think my tail is not exactly straight, but it should be okay. I don't think anyone will notice. So that's where we're at. It really is barrel shaped. It's a bit hard to see. The other thing I did is I actually measured it, weighed it. I wanted to see how much that skin weighs. The skin is about 9 kg, and I believe the frame is 14. This timber frame, that's with all the steel bits and pieces on it. So what does that make? The rear half of the body is what, 24 kgs, 23 kg. Once I do the boot lid and it's got the locks and things on it, I guess 25 kg, probably not even that, which isn't too bad. That's for the back half of the body. The front half, I think it was about half the weight. So all up, the body shouldn't add too much weight to it. And then I've had a bit of a clean up, and yeah, the TIG is so much nicer because you don't have to deal with that corrosive flux. And I'm pretty sure the problem I had with the welds cracking before, I don't think the weld was actually cracking. They will if you really hammer them and harden them. But I mean, the aluminium will do that as well. I think it wasn't cracking, it was just really poor penetration, which meant it was just splitting on the seam again. So now I've got the hang of TIG. I still don't know why I all of a sudden got the hang of it, or I was not able to do it properly before. I have found now I didn't even think about the foot pedal, I just used it, and I was able to sort of feather the amount of current. I'm much more able to control the heat, where you can see it starting to melt and you can back right off. And and I'm just a lot better at seeing the weld pool and seeing what's going on. And the AC, the cleaning effect of the AC TIG really makes a difference. When I was going over the welds where I'd used the oxyacetylene, you could see the impurities coming out of it. I guess it's the flux that's still in there, because you can never fully get rid of it. But yeah, I think that's going to look pretty good when it's done. Now, I think that's it for me for this weekend. I've been pretty busy on the Velicet and the Riley. I'm pretty knackered now, so I think I need a holiday after my holiday.